Hi, welcome to Modern Geospatial. I'm Adam Simmons here at the GEOINT 2023 Symposium here in St. Louis, Missouri. I have the pleasure of talking with Sean from Google. It's been a while.
Good to see you, Adam. It's been a while.
Yes, absolutely. So let's, well, first of all, for folks who don't know you, can you tell a little bit about yourself and how long you've been in the community?
Sure. So I'm Sean Wohltman. I am Google's global head of cloud geography, and I've been in the community for about 20 years. I was at NGA first, and I came to Google 15 years ago.
Excellent. And a lot of projects with Google, starting off with Google Earth and the community significantly evolving from then where it is now, right?
Absolutely, yeah. So, Earth really democratized access to geospatial information, gave people the ability to go and explore, and then naturally people wanted to analyze. So that's where the next project, Google Earth Engine, got its foundation, is bringing in all this geospatial data and then being able to analyze it at scale. So right now we have a data catalog that's 80 petabytes. It grows by about 1.5 petabytes, 2 petabytes a month, and over 1,000 different data sets. So primary data sets like Landsat, Sentinel, but also secondary data sets that our customers, such as USDA, USGS, generate on the platform and then share out with researchers and commercial users.
Well, that's a good lead in. So what do we got here behind you?
Yeah, so one of my colleagues has been working on a new paper for t-testing. Basically allows you to use Sentinel-1 to do broad area and bomb damage assessment. So what used to take an analyst a really long time to go in and manually inspect each image, we can now wait for enough coverage for Sentinel-1 and analyze the entire area. So this is an article from The Economist that describes that process. And you can actually see that we get down into the building level detail in each one of these cities, and then we can summarize that across the entire country. So this is a really useful tool for bomb damage assessment, but also when you had the event in Turkey, we had somewhere in there, we were able to rapidly detect what buildings were impacted and where there could be survivors.
Excellent. And that's only one example. This is an example of a product that The Economist made from Earth Engine, correct?
That's correct. They did a whole full analysis and summarizations by where most buildings have been damaged, et cetera.
Well, let's talk about Earth Engine specifically, right? So how many data sets? Because you don't just act as a imagery processing engine per se. Right. You're a data warehouse too. And so give us an example. You mentioned a couple, Landsat, Sentinel. Give us an example of some more of the data sets someone can find and look to Google for. Or quick access, where normally some of those data sets might have a couple walls behind them, soft walls. Sentinel, you have to go through this,
right?
Things like that.
Yeah, absolutely. So the whole idea with Earth Engine is not just make the data that you can find it and have to download it. No, it's all analysis ready. And so you mentioned the major catalog contributors, Landsat, Sentinel, but we also have data from NOAA and from NASA and from JAXA and from DLR in Germany. So really what we're looking for is that global coverage wherever possible, high value data, and make it easier for users to use it without having to go to the old put it in the shopping cart and download the files and unzip it and everything like that. The whole idea is with a single line of code, you reference the entire collection, whatever it is that you're working on. And our producers, like I mentioned, USDA, they do the crop data layer. So they're doing an analysis of all the different crops in the United States every single year. They'll publish that, and then people use that to create machine learning that can take, this is in Brazil, but this is, USDA doesn't operate frequently in Brazil, but they were going and training a model off of somewhere that's geographically similar to this particular soybean plantation in Brazil, and they're classifying it on the fly here with that training.
That's incredible. So in terms of, can you talk about where Earth Engine was maybe a couple of years ago and where you are now, and perhaps even where you're going, for example? I know this was, at one point, this was research and educational access at first, but then you opened it up to a larger audience.
We did, yeah. We always had the ability to kind of experiment for commercial purposes, but it was actually a sense from our customer base that said, public sector agencies wanted to use Earth Engine operationally, and our terms of service didn't provide that. Didn't have a way to differentiate the compute to give them, paying customers better capacity, or an SLA. And so we went through a migration. Earth Engine's now over 10 years old, and it started out as one big monolith where everybody's kind of all sharing and touching each other, right, in a Google project. Now it's a full Google Cloud project, which gives us segmentation. It's FedRAMP moderate. So your data is your data. And when you're a paying customer of Earth Engine, you're able to have priority compute. You're able to better estimate how long jobs are going to take, and that's really important, especially if you're doing something like wildfire detection or something that's time dependent.
Excellent.
Yeah.
So where are you going with this?
Yeah, so we're continuing. We launched June 28th as a generally available Google Cloud project. We've been building out a partner network because we're finding that customers look at it like a funnel, right? We've enabled this awesome research platform, and we continue to do that. We're still committed to doing that, and researchers will still continue to be able to develop on Earth Engine. But what's happening is that people find operational use cases, and they need help. They're like, oh, this is cool. I want to do this. I want to solve this intel mission, or I want to solve this, biodiversity study or climate risk. And they need help doing that. So we've been working on developing a partner network to provide services that are able to help customers implement the literature into an application. Where we're going is continuing to support more file types as new data formats come available, continuing to expand our catalog, regionalizing so that we have data in other locations, because we're serving a global community and other countries sometimes want to process their data in their region. So there's a lot of that occurring. And then there's integrations with products such as BigQuery. So BigQuery was a vector data store, and we're working right now on the ability to export directly from Earth Engine to BigQuery. So when I do an analysis and summarize it up, and I want to generate a vector table, rather than pumping it to cloud storage and then ingesting it to BigQuery, it's just one step. So we'll see further integration with BigQuery on our roadmap as well. We have companies that are streaming billions of points and vector data into BigQuery, and now they want to be able to analyze rasters in the background.
Yeah.
So that tighter GIS integration is coming up this year.
Great. One last question on Earth Engine, specifically on what you're doing. So this audience here obviously is a bit unique, right? So how would the U.S. government leverage something like Earth Engine, where obviously it's integrated within your completely open and classified servers? How do you pull a service like this on the inside?
Yeah. And NJ has been a tremendous supporter of the platform for a long time, operating on the internet level. We say government, there's really two audiences. There's our civilian users who continue to do this for agriculture, natural resource management, right? But all of those things also are intel questions.
Absolutely.
So that's what's really interesting. And if you look at, take a look at something like a reservoir, right? Well, this reservoir is in Mexico, which had gone through pretty drastic drought, right? Example here, this is our partner Climate Engine, built a nice little app on top of Earth Engine here. Just understanding that this is an extreme drought using this NOAA model. And because of that, this reservoir was dropping precipitously. So we've got, from 100 down to 60. So like a 40% drop in this surface area. And what ended up happening in this case was it sparked a little bit of a revolution. By treaty, Mexico has to give this water to the United States, a certain flow. They were behind on their water payments, if you will, in 2020. And so that impacted the local farmers. And the local farmers then basically had to figure out, hey, this is our livelihood. And they surprised the National Guard, captured the dam, and held it for a month. So we have a real conflict situation because of water. And this is something right on the U.S. border.
Yeah.
Right? This has been called out most recently in the DNI put out a national intelligence estimate on water and other climate-related sparks that are going to continue to be a problem in the world. And Earth Engine allows you to build a baseline. So something that really is agriculture is also intel. If that makes sense.
It does. It does. So my final question as we wrap up, maybe it's more of an insightful on what's been developing here at in the industry as a whole. In terms of machine learning ops,
yeah,
a lot of this is terms of Earth Engine is well established in op, but in a lot of it's users go in and pull what they need out of it, work within their own workflows. How are you incorporating things like machine learning models or models built within Earth Engine to take advantage?
Great question. And so we made a design decision a couple of years ago, back in 2019, to say that we will continue to support classic machine learning, supervised classification, random forest type stuff inside of Earth Engine itself. AI changes so rapidly. We felt it was better to allow Earth Engine to orchestrate geospatial data going to AI predictors such as Vertex AI, And so that's a lot of connectivity that's happening this year. I'll give you a brief example of that. So for instance, we come back to water. In the Western United States, this is our partner OpenET, working with NASA and USGS. And what you're seeing here is the actual water that's evaporated through vegetation. And there's a number of different competing models here, but you can see the disparity if you look at this area. This is Eastern Washington. And you see these fields that are, if you look at almost no water. This is severe drought occurring in our Northwest. So these fields are being laid fallow. Some of them are irrigated. You can see that there's some green in there. But then you look at these set of pivot irrigations, right? And you're looking at extreme water usage. Well, that's happening to the aquifers. That's utilizing some of the local water. And states are getting really, really interested as the water supply is reducing. How do they manage this? How do they make sure that it's equitably sourced? And so where machine learning comes in is what's really neat about what OpenET has done is that we get this analysis on a field level, right? So you can come in here and you can get the analysis for that particular field. And there's over 3 million of these in the Western United States, but there's billions of them in the world, right? So the question becomes, how are you possibly going to be able to build these vectorized fields? And that's where something like machine learning can be very, very helpful. This is the open segment anything model from Meta. And what we're looking at here is connecting to Earth Engine to pull a Sentinel-2 cloud-free mosaic.
So the Jupyter notebooks are directly connected to the Earth Engine AI, and then they'll be able to hold the data within the Jupyter notebook to kind of run a rough sample of it before they integrate it with the pipeline.
Correct. Most of our advanced users are using it Earth Engine through Python and taking advantage of a lot of the libraries that are there. But yes, this is a call to the REST API to generate that image. And this is really kind of just testing. What you would do when you want to scale this up is you would probably use something like Kubeflow from Vertex AI, have the data from Earth Engine, send it out to many, many machines to do these classifications, and then you can segment every field in the world. And that's what we're going to do.
Okay. Do you host these models within Earth Engine, allow them to do that? Or do you facilitate the catalog of models for your users? Or is that something?
So we do have the ability to import models into Earth Engine. You can ingest TF records for TensorFlow. And then there's, again, certain ML that can be run inside of Earth Engine. Increasingly, though, models like this, which are written in PyTorch, will be hosted on Vertex AI, discoverable on Vertex AI. And it's that orchestration that Earth Engine and Vertex AI do together that allows you to use them at scale.
Awesome. Well, we're going to wrap up, Sean. One last question for folks who are interested in joining the industry, young people, for example.
Yes.
What would you say to them to inspire them on why you like doing your job so much?
Wow. Okay. So
that's the hardest question.
Yeah. We have a very vibrant community. For me, it's always been connected to the mission and impact, right? Whether that's impact from a climate sense or impact from a security sense, it's an exciting field. And the technology, just when you think you got everything down, something new comes along. I've never been bored in 20 years of doing this, and there's always something new and exciting. So. And hopefully that's a big draw, is just feeling an impact, feeling like you're making a difference in the world, whether it's helping to reduce water waste or increasing biodiversity from a corporate standpoint, whatever it is. GIS is at the center of it all, and so it's an amazing field. And so it's a lot more fun than like just basic boring computer science. Like, it's applied, right? It's you can see the results, and you can see how it impacts the world at the end of the day.
Awesome. Well, thank you very much.
Yeah, thanks, Adam.
I'm Adam Simmons with Project Geospatial here with Google at GEOINT 2023. We'll talk to everybody next time.